So we're solving another question from paper 2 for the year Jan 2017. So the first question here is asking you state the principle of moment. So it's very easy. You just need to write sum of all. Just remember here you have 2 marks. So you need to write it down. Sum of all clockwise moment is equal to the sum of all anti-clockwise of all anti-clockwise moment. And then you say that in equilibrium. This is very important. If you don't write in equilibrium, you will not get 1 marks. This 1 marks for this portion specifically. Okay, I have seen a lot of students making mistakes here. For part B, it's asking us that, okay, how the student should use the electronic balance to, you usually know that for electronic balance we measure mass. So when it comes to electronic balance, they're giving you options that, okay, you can't use Newton meter. That means you can't measure force directly. So here we will, when we need to answer that, how are we doing this calculation? We need to say, okay, we are going to measure the mass first using the electronic balance, and then what we will do is we will multiply it by g. So the answer will be measure the mass of the strip, and then the answer is multiply by g. So you get 2 marks here. For the next question here, so this is how the student could improve the precision. We have discussed this before. There's another video about the experiments where we have discussed this about all the details. So you can use anything, but there is a specific thing that I want to tell you here. If you have a look here, all these measurements are in centimeters, right? But they have used this one as a meter rule. So understand, a meter rule basically doesn't give you very details, right? It either tells you information about, it should tell you the better information about the meters or any units above. So for this kind of question, if you look carefully, you can just mention avoid take better ruler or something like that. But to be specifically in this part, because they are asking you how you can precisely measure one of the measurements, how you can improve the precision of the measurements. So here we are going to say that use a ruler with smaller division, or you can directly say use a ruler uh, with smaller division, or you can directly say use a millimeter ruler. Use a millimeter ruler. So if your units are in millimeters, when you convert them in centimeters, they're going to be very accurate. This is just a straightforward question about the equations. I wrote this without wasting time. And now again the same question here, principle of moment. Uh, just one more thing that you should be adding here, because this is from the previous syllabus, but the criteria or the marking or the writing procedure doesn't change. So this is important that you practice this as it is here, because in your exam you will have similar questions and you will be marked similarly as well. So we all know what is the principle of moment, that anti-clockwise moment is equal to the clockwise moment. That means your this moment. So here, when you are given a question like this, find the pivot first, and always calculate all the distances from the pivot. So if I have a look here, this is a force of 0.2 Newton. And this is a distance that is 50 centimeter, 80 centimeter. but your distance is at 50, your pivot is at 50. That means this distance is 30 centimeter. And then we have something here which is 40 from here. Okay, that means this distance will be, I use a different color to explain, so this distance will be 10 centimeters. Okay, so this is it, and this will give me a anti-clockwise rotation, so anti-clockwise moment, and this will be a clockwise moment. So of course I'll just use this force, and there's no other forces. They are the two that's balancing it up. So I can use that. Okay, this one first. I don't know the mass of this. I'll take that as W. So, or let's say it's force F times 0.1 is equals to 0.3 times the force. So the force here was 0.2. So don't get confused. This is the length in meters. Length in meters. This is the length in meters. Length in meters. That means we had 10 centimeter, we divided by 10, 100 to get 0.1 meter. So I wanted to show you here that F is equals to directly 0.2 times 0.3 divided by 0.1, and the answer is 0.6 newtons. So this is important to remember when you're talking about moment. Your force should be in newtons, and distance should be in meters. We could have skipped here because both of them was in centimeters, but just it's better to practice it. Um, like you don't know if in the exam they will ask you to find the distance, so you have to convert it or use other units. Then the last one, explain why the reason of the mass weight of the rock will be different from your calculated. Just 1 mark. Very easy answers. So if you look carefully here, what happened? They have a bucket as well, they have a string as well, and we don't know if this is, we are just considering the mass of this rock inside here. So all the other, but this bucket definitely has a mass, right? And we haven't taken the mass of those buckets, so they will be different. Or you have paper clips, you have all sort of things. So I can say the answer for this will be that the weight of the beaker should be subtracted. And this is it. Good enough. You could have talked about this paper clip as well. Here, that would have been the same thing. Another important thing was center of gravity as well. The center of gravity of the ruler we didn't consider. We just thought that okay, this is at uniform. Center of mass was ignored. But I think it's better to talk about the relevance of this rather than then. And again, anyone. You don't need to write both of them. I'm just discussing, so I'll discuss both. So the next question is about this. We'll start solving. So the next question we are solving is Jan 17, paper 2. So here the first question is asking you which of the following quantities is scalar. This is easy answer, should be energy, because we know acceleration, force, and velocity. These are vector quantities. So of course energy is scalar because it has no direction. Uh, Again, read the question very carefully. We're just skimming through. There's one force on this side and there's another force on this side. So definitely whatever is the greater force, which is this one, will be on the resultant force will be on this direction. So the resultant force, very easy. If you want to find the resultant force, just use 8700 take away 1250, and this is equal to 6750 Newton. And we are good, we don't have any other forces, so only two forces in two opposite directions. Um, Another question here is that the formula for resultant force, straightforward answer, already written it for you. Next, number 3 is the mass of the van is 2500. Calculate the acceleration of the van. Very straightforward. Force equals to mass into acceleration, because we are trying to find acceleration here. So acceleration should be equals to force by mass. Remember, here they're talking about the resultant force, which is this one we just found out. Even if you didn't know the resultant force, you have to subtract it to find the answers. You can't use this or this. It has to be the resultant force, okay? Resultant force is the force that you get after deducting all the forces in opposite direction. So here the mass is 2500. So the answer is 2.7. And of course the unit is meter per second square. When you have Newton and you have kg, you get your answers always in meter per second square. That's a unit of acceleration, SI unit. Next one here, they're asking you, so if you remember, this is pretty much the same question as terminal velocity. The graph looks very similar. So here they give you 5 marks, which means it's very important. You should be getting all 5 marks. Explain the shape of the graph. So this is the part. So they want to know what shape is what. So here we will see that this is velocity, this is time. So we need to explain how the velocity is working. And then he says use the idea about forces. So you need to explain why the shape of the graph is what. What is this, maybe a line representing, what is this curve representing here to here, and then what this horizontal line is reflecting. So here we will divide this, okay? So first understand that you are basically having a constant speed at this portion. Constant velocity, I can say, because your velocity doesn't change. From which portion? From here to here, which is a straight line. In fact, from here to here is a straight line. So we'll say this portion is a straight line. So of course, for the rest of the part, what's happening here is that you are accelerating here for this portion of the graph. So this portion of the graph is acceleration, and of course the acceleration is also changing with time. You have greater rate of acceleration here than you have here, okay? Because you know, as the speed increases, the air resistance also increases, the frictional force increases. But here we will need to know that we are talking about a vehicle here. You have a air resistance on this vehicle. Of course, there are frictions as well between the tires and the road. So there is friction. So we'll talk about that as well. Because if it doesn't mention, of course, the road is never going to be a smooth surface. That means you will have frictions on the road. So the first thing we will say is that there is a resultant force. There is a resultant force. And if you remember, the resultant force is on the right side. So we'll say there is a resultant force on the right side. The next thing we'll say here is, so there is an acceleration. Because they're asking you to explain the shape of the graph, you need to explain what till what point. That's what we discussed in the first. So I'll say there is an acceleration starting from 0 to 50 seconds. Okay, and then we are saying as the speed increases, as the speed increases, the air resistance and frictional force increases. So the rate of acceleration decreases with time. Okay, then next we're gonna include that. Okay, what's happening then? So driving force equal to air resistance plus friction. So acceleration equals to 0. Of course, I'm just writing it so you understand, but make sure you write in words. Therefore, resultant force is 0, so acceleration is 0. So the car reaches constant velocity after 50 seconds. So because it's a very big one, we'll just quickly summarize what's happening here. So here the car is accelerating at a greater rate. Then understand that the whole portion the car is accelerating, right? This whole portion the car is accelerating, but your acceleration rate is decreasing. That means if you're accelerating here at 10 meter per second square, you're accelerating here with 2 meter per second. That means your speed is going up with 2. And why is that happening? The reason why this is happening here, because as the time goes by, the air resistance and the forces increases. So your driving force doesn't change, right? We know that the driving force is always 8,000. The driving force didn't change. So if the driving force doesn't change, the resultant force will decrease if air resistance increases, right? As a result, you will have your acceleration with time. So this is what will get you 5 marks here, important 5 marks, and we'll move to the next question now. So the next question we're doing is from Jan 2018, and before I go here, I want to correct something in the previous question. So here we made a mistake. So initially this was 8700. I want to correct it and make it 80. I think I got this number wrong. So this should be 8,000. This is what we have here. So this should be 8,000, but this answer is correct. So you can move on with this one. Okay, let's move to the next question here, which is Jan 2018, paper 2, and we are doing from number 4. This question is about momentum. So make sure you read the question very carefully. There's a lot of answers that we will drag out from the question. So here it says that the particle A or the ball A has a velocity. This one doesn't have a velocity. So for this one, we know momentum is equals to simply mass into velocity. And we denote the momentum for B. Let's say this is momentum for B. And this is what we are doing is before collision, okay? Before collision. So I'm writing on the spot. Do not write in the exam in this spot. So this should be 0. We can find the momentum for this A. And we'll do it here and we'll show how it's done. So this A has a mass of 1.6 if you read the question. In fact, both of them has a mass of 0.16 kg. Because it's in kg, we don't need to care much. So 0.1 kg times 10, which is 16, right? Or 1.6, sorry, it's 1.6, not 16. So I'll definitely do the calculations here. So if I say moment before collision and after collision, if I compare the two scenarios after collision, so what's happening here? Let's see. So before collision, you have 0.16, which is the mass of A, times 10 plus 0. So what are we doing here? Momentum of A plus momentum of B. Since the velocity is 0, so the mass of this momentum of B is 0. Because if you multiply anything with 0, should be 0. Now, after collision, what happens? If you read the question here, it says that the ball B moves in the same direction. So what's happening here? And ball A continues to move in the same direction as well. Another thing, if you understand, when ball A and B hits, they both move in this direction. That's what it says. If you read and don't understand it, it's a problem. So it says in the same direction as A. So where was the ball move coming? So this ball was coming here. It hits the ball. If something comes here and hits you here, there's no way you can move in this direction, right? It can never make sense. The only possible option is if this ball A comes here, hit B, the only thing that can happen is both of them either move this direction, or another possible scenario can be that A moves in this direction. But because we don't know, because they have already told you that both of these particles are moving in this direction, so we will skip this option. If it was not mentioned, we could have taken that into account as well. We will show you, especially if you go to your A levels, you will see these sort of things coming up where you don't know what is the direction and you need to find it with the calculation. So here another information was given that B has a velocity of 8. So velocity 8. I already know the mass is 0.16. And this one, I don't know the velocity, so I say velocity of A is V. Mass again is 0.16. So let's do some calculation here. So P of A is equals to 0.16 times V, I don't know the velocity, plus 8 times 0.16. And this total comes up, I don't know, but what I want to show here, in fact I won't do the calculation now, I want to do the direct calculation here. Now, can I say 1.6 is equals to what I get from here is equals to this 0.16V plus 8 times 0.16, and if you make V subject here, which is 1.6, take away 8 times 0.16 divided by 0.16. The final answer is 2 meter per second. Okay, this should give you 3 marks, should be good enough. The next question here, it says during the collision some kinetic energy is lost. Calculate the kinetic energy. Okay, another thing, let's find the kinetic energy here. Let's see the kinetic energy of A, half times mass times velocity square. So what is the half times 0.16 times 10 square? This is equal to 8 joules, right? So I can say, okay, half times of A is equals to kinetic energy. It's not probability, or A is equals to half times 0.16 times 10 square, which is 8 joules. Now, if I come to the next portion here, it says kinetic energy of A after collision, after collision. So AAC, kinetic energy of A after collision, okay? Half times 0.16 times, what do we get? We get this as 2. And this should be equal to, okay, another thing here, another mistake that I spotted, should be square. So this is 0.32 joules kinetic energy of B after collision should be half times 0.16 times 8 square, and this is equal to, if I do the calculation, 5.12. Now if I want to find the kinetic energy, I can say that, okay, before collision my kinetic energy was 8 joules. After collision my kinetic energy is 0.3032 plus 5.12, and this is equal to 2.56. Now because I'm explaining, I'm writing it bigger, but you should be in the exam trying to write in the space that's given. Okay, and this is the energy. So where is this? This is the energy that we say energy wasted. It can be wasted in different form. It can be wasted in heat. So many times they ask you, okay, what happens to this energy? So you can say, okay, the energy is lost as heat or sound or in friction. Many reasons can be true for this one. Let's move to the next one now. The next question is from this year, which is June 2018, paper 2, and we're doing number 3. Just reading at the question, for these kind of questions, you should be reading the question very carefully. There will always be information here. So I want to read this line for you. So the student uses the apparatus to investigate how the angle of ramp affects the time taken of the toy to travel down the ramp. Okay, so there's two things. He's just trying to investigate, doing an experiment, that what can be the factors of angle of ramp and the time taken. Okay, two different variables. Understand, for 90% of the question, it's not a golden rule, but for 90% of the question, the first one they will say is x, and the second one they will say y. And also, x is always independent. That's what we meant by x, and y is always dependent. So this is the case, but then again, you need to use your logic as well. Of course, the angle of ramp will fluctuate, will have an effect. If I scroll back here, so after the interruption, okay, so where were we? Y will always be dependent variable. Again, I was explaining that angle will have an effect on time. If you change time, the angle won't change, but if you change the angle, the speed that it comes down will change, so eventually will affect time. So in this case, time is dependent on what? Dependent on the angle. Okay, there's no chance that you can increase the speed and the angle of the slope will change. That cannot be the case. Okay, so as I told you before, in experiments we will have independent, dependent, and always a control variable. Just look at the question and you will understand that there are 4 variables they are talking about. So definitely one has to be x, one has to be y, and rest of them has to be 2 control variables. In because it's 4 here, so it has to be 2 control. If they would have discussed about 10, I would say that 8 would have been control variables, but we will only test one independent and one dependent. So we always test that, okay, if I change independent, meaning x, what is the effect on y? So if I come back here, so some of them are here independent and dependent. So let's go through. type of the toy car. This should be control variables because I told you already that angle and time taken. Let's do this one first. So the time taken is dependent variable and the angle should be independent as we have discussed. And then so you can just blindly say okay, rest of the two will be control variables. Now here they have asked you to draw a table with these results. Again, you're getting a hint that okay, one of them is an x, the other one is y. So first, let's do it. We're gonna say okay, I'm gonna have angle. Always try to write the x-axis, x values first and y values after that, and then I just fill up the table. I'm just gonna save time and make sure this is because you have units here, make sure you write units here as well so that you can say that okay, all the angles are in degrees and all the times are in seconds. So I'll quickly say okay, it's 10, 1.16. I don't want to write the units now again because I've already mentioned on top. So 860.59 and this is 50 degrees, 20 degrees, 30 degrees, and oops, I think I missed someone. So the rest of the values are here and we'll proceed to the next question. So here they ask you one of the anomalous results. So as you can see that what will happen, the angle gets higher and if you're dropping it from slant, of course you can understand that this one will go faster, something that we have all done in our childhood. So as your angle increases, this car will go slower than compared to this car. Okay, so as the angle increases, your time should decrease, which is an inverse graph. We know that inverse graph looks like this. Okay, so they'll ask you for anomalous result. Just looking at it, I can say this is an anomalous result because we have a pattern the other ways. So just how the student should deal with it, just say that eradicate the or exclude the and exclude it, or I can say ignore the value and repeat, or you can just repeat it. Okay, just repeat it will get you 1 marks as well. Then you say that okay, draw a smooth graph. So we'll just quickly draw a smooth graph. So a smooth graph is something that I expect you to do it properly at your own time and practice it enough so in the exam you don't waste too much time here. The next question here ask you suggest why the student did not start from this. So you can't have time 0, right? You cannot have an angle where your time will be 0. So you eventually make better use of the grid. So I'll say okay, makes better use of the. So he's trying to use all the values that he has for the grids if you have a look here. Otherwise, if he started from 0, he might not have used all the graph that he had. And also you won't have any readings for T0, so there's no point of taking it. Yeah, that's 11 marks. Should be good for you. We're doing the next question, which is question number 8. This question is about moments. So you know about all the moments. So the very common question is principle of moment. Just memorize it. You will get it for 1 marks, even for 2 marks. This is good enough. And here, if you read the question here, what it says quickly is you have two planks like this. The person is standing here, another thing that's balancing here. So we have to take one of this as pivot. So he's asking you to find force x. Force x is this one. So because he's asking you to find force x, we can't take this point as pivot. You know that to do the calculation where anti-clockwise moment will be equal to clockwise moment, you have to have a pivot. So we can't take this point as a pivot because we are finding this force. So this is not pivot, so we will take this point as a pivot. Okay, it's up to you. You can consider pivot, but usually we try to take the pivot where it's easy for us. Now, you will have two forces. Of course, there will be one anti-clockwise, the other one is clockwise. If this is the pivot, then you have a clockwise moment, which is this one. This is clockwise moment. I'm just gonna erase it so you can see the value clearly. The arrow is correct. This is the clockwise moment that we have. And another anti-clockwise moment will be this one, which is balancing it. Otherwise, how is this person stationary? Both have to be equal. If they're not equal, you can't balance it. You will move either right or left. Okay, so I can say that, okay, all the distances will be starting from this point. So let's do the clockwise first. I'll say moment is equals to, because it's 4 marks here, I will try to explain as much as we can. Force into distance, and we will also use the principle of moment. They are also giving you hints with this sort of things when they ask you that, okay, if you know the principle of moment, you can apply it down here. So here we are having a force. So the force is 620 Newton times 1.4 is equal to another one here, which is force X and times something. So what is this something? This something is basically this distance. So I know it's 14.4 plus 0.6 is the total. So 1.4 plus 0.6 is equals to 2.0 times 2. So I'm just gonna say this is X. Now if I make X subject, I can easily say 620 into 1.4 divided by 2, and this is equal to 430 newtons. So you get 4 marks for this calculation. Now here it says that the person is moving on this side. So what happens if person is moving that? Because moment is equals to force into distance, if he move in this side, that means this distance that you have here will start to get reduced. This distance that you have here will decrease, and if the distance decreases, then obviously your moment will decrease because your force is constant, your force is not increasing. So I can say what is the effect on here on this force. Okay, so you don't need to create extra forces. So the first thing we'll say that this force X will decrease. Force X will decrease. Okay, and then the explanation we will have provide is because the distance decreases, because the distance from left hand from okay, spare my bad handwriting, left hand pivot decreases, therefore clockwise moment decreases, therefore clockwise moment, or let's write down the whole thing so that no one gets confused. Clockwise moment decreases, and then you say okay, so anti-clockwise moment will decrease as well. Anti-clockwise moment decreases to maintain equilibrium. So if you remember the formula before, we were saying force 1 into d1 divided by, if this is x2 and this is d2. So what's happening here is your distance here is this decreasing. So if this is decreasing, so your x has to decrease, because I can say that x2 here is proportional to d1. If you remember, because this unit and this unit is constant, this hasn't changed. So we can move with this fact here. We'll do the next question and you will see that this is very similar. So let's start. Another question from June 2018, but international paper. So if you look at this, if you remember, this is exactly the same question that we have just done before. The question is about moments. So we will go through this very quickly. So if you read the question here very carefully, what he's doing here is using this plank, he's basically measuring the basket of banana and he's using this movable weight. So first question asks you explain, draw an X on the diagram to show the pivot. So here, this is a weight. So you have a moment across this and you have another moment across this. So definitely this is going to be your point of pivot. So I'm just gonna say, okay, I'm gonna make this as X, or you can say here it's an X, up to you. Then the next question here, it says support the basket of 14.4. So this distance is 14.1 and 1.25, 84.6. Understand that this is in centimeters, but both of them is in centimeters, so you don't need to worry about it. So if we want to find this, for this one moment of banana will be very easy, 14.1 times the mass, and we don't know the force. So here we will just say, okay, force or weight of the banana. For this one, we know it's 1.25 times 84.6. So I can say 14.1 times F is equals to 1.25 times 84.6. F is equals to 1.25 times 84.6 divided by 14.1. And then if I do the calculation, if you just put into your calculator, you'll get 7.5 Newton, because this was in Newton. So my answer will be in Newton too. You don't have to do any further calculation for this. So you get straight 3 marks for this one. The next one is very easy, mass. So we know weight is equals to mg, and you are wanting to find your mass. So mass is equals to weight divided by gravity. Weight is 7.5 Newton divided by 10. 0.75 is the answer. And then of course you want to do more, but this is, remember, they are asking you to find for one banana. You have 5 here and this is in kg. So I want to divide it by 5 and I want to multiply it by 1000. So I'm just gonna quickly mention why 1000. So the answer is in gram. So this is incorrect. The correct answer is 150 grams. To convert to gram. And why 5? Because there are 5 bananas. 5 banana. They have mentioned it somewhere in the question. So that's why you need to read the question very carefully to plug out these informations. So 150 is the answer. We'll move to the next question. So it says suggest two ways that the student and the fruit seller could alter his yard arm so that he can measure larger weights. So he's asking you for two. One of them is definitely that you increase the length. Length of what? Length of the arm. So what I'm saying is if you make this one, if you increase this distance or you increase this mass, you will have greater moments. So you can easily balance it out. So I'm gonna say use a yard arm with a longer distance. This is one, and then I'll say heavier weight, heavier weight, and this should give you 10 marks straight away. And you know, if you do the repeated questions, you will get same type of questions over and over, and this will save a lot of time in your exam.